How long would it take us to go to Proxima Centauri? Proxima Centauri is a low-mass star which is the nearest star located in the southern constellations of Centaurus. Have you ever thought that the nearest star is so far away that we couldn't make it there in a single lifetime? However, technology has advanced to a new level and presently it is possible to reach the nearest star, although it will take longer. Therefore, to know how much time we will need to reach Proxima Centauri, make sure you watch this video till the end and subscribe for more. Here we begin. Let's first look at NASA's New Horizons investigations that finished many years back. The missions was a 3 billion mile trip to Pluto. That outing itself needed 9.5 years. New Horizons was touring at speeds that top 52,000 miles per hour, but even at that speed, it would take about 54,400 years to reach Proxima Centauri. There are certainly faster probes out there. You will find that a couple of years ago, NASA's Juno attained tremendous velocities of about 165,000 miles per hour when it reached orbit around the gas giant Jupiter. At that rate also, the probe would enter Proxima Centauri in nearly 17,160 years. There are actually some ways to reach this nearest star. The first one is ionic propulsion, formulated to shift unmanned space surveys across the galaxy at faster velocities. This latest craft utilizes solar power to give rise to its ion thrusters to move, resulting in a relatively fuel-efficient network in which only small quantities of xenon or another fuel are required for the trip. Its fuel efficiency would make ionic propulsion the most logical and reasonable technique for voyaging to the next nearest star. Back in 1998, DS-1 or Deep Space One came to be the first spacecraft to utilize ion drive technology, and during its go to assess the new technology, DS-1 operated to achieve a speed of 35,000 miles per hour or 56,000 km per hour. At that rate, it would need 81,000 years to enter Proxima Centauri. Still, modifications in the layout of ion thrusters could decrease the travel time, but not to that of a normal human's lifespan. At present, the fastest means to traverse through the universe is with gravity assist, a technique by which a spacecraft utilizes the gravity and orbit of nearby planets to propel it at a fast rate. In 1974, it was utilized by the Mariner 10 spacecraft's outing to Mercury, where the gravitational field of Venus was utilized to catapult the vessel forward. After that, the NASA Helios 2 space probe in 1976 came to be the fastest artificial object ever developed after attaining an absolute velocity of over 150,000 miles per hour or 240,000 km per hour, utilizing the global velocity achieved from the gravitational pull of the Sun. At this rate, it would take around 19,000 to 76,000 years to catch up with Proxima Centauri, and that depends upon the speed that the spacecraft was competent to enter. There's also one technique called nuclear thermal and nuclear electric propulsion. Here, propulsion has never been utilized in a spacecraft but uses nuclear engines to generate thrust. NTP or nuclear thermal propulsion rockets and NEP or nuclear electric propulsion rockets utilize uranium or deuterium-based reactions to stimulate the spacecraft through either nuclear fission or nuclear fusion instead of utilizing chemical propellants. The very advantage of using the nuclear reactions is that it has more power and energy-giving capacity than is achieved with chemical propellants. If it could be safely refined, NTP or NEP would be cost-effective. Then this would permit lightning-fast travel through space with reasonable expenses. Utilizing this technique, the time which is needed to enter Proxima Centauri could be decreased to 1,000 years. The last invention that has decreased the time to reach the nearest star is the EM drive or electromagnetic propulsion drive. It was created here on Earth but has never been utilized in a spacecraft. And this has led to many questions regarding its effectiveness. Some speculate that it would only partially work as it goes against the natural law, which is the law of momentum conversion. This category of thruster does not need any mass, such as ionized particles, to stimulate its activity. Rather, it utilizes solar power to generate numerous microwaves, which bounce back and forth inside a sealed cone to establish thrust in the path of the cone's narrow edge, equated to the Starship Enterprise impulsive drive. Some researchers have indicated that the thruster could theoretically be utilized to tour through space at faster velocity than we have so far been competent to regulate, and that Proxima Centauri could be entered in only 100 years. Yes, you heard it right. You can reach the nearest star in just 100 years. This would certainly take your lifetime. You should keep in mind that expediting a craft to higher velocities with multiple humans on board is not, however, possible. There's been a mixture of brilliant notions roaming around on how reasonable to get to Proxima Centauri within an adequate time frame. But whether you are speaking about ionic propulsion methods, EM drive, antimatter engines, and nuclear thermal or electric propulsion procedures, the time frame required is constantly thousands of years. So, that's all for today. Did you find this video helpful? Let me know in the comments. Make sure to subscribe and smash the bell icon to get new updates. See you soon.